whole file is 4, you add another 518 bytes to the size of this and take away part of your program area. If you don't have a disk drive in, this area isn't reserved. This area gets reserved when the computer powers up, when it starts to go through its power-up routine, it goes through the monitor, and then it finally comes out, and it does a scan through all the cards. And in each card, there's a pointer, and it says, is there a power-up routine in this card? And if there is a power-up routine, it's executed. And if there isn't, it just passes itself on to the next card. And in the case of the disk controller card, there's a power-up routine. And basically all that power-up routine does, one of the things that it does, is it goes through this area and clears it out. It zeroes it out. And then it starts at the top and it writes just a few bytes of pertinent information up here. It puts a validation code, the size of BDP RAM, and how many files are open, call files, type of thing. And then this space is then just reserved for the disk system. When you do an open number 1 DSK, whatever, and you tell it to print number 1 such and such, it doesn't always go right out to the disk drive right away on that print. And what's happening is there's a 256 byte buffer in here for each file open. And when that buffer starts to get full, then it goes ahead and writes it out to the disk drive. So you're not constantly writing. That's why sometimes when you do a print number 1, A, and A is only a variable, and the variable is only 8 bytes at that time, it doesn't do anything with it. It just puts it right down here in this buffer. And then when this buffer gets full, it writes it out to the disk. And that's why if you do a function quit before you do a close number 1, you'll lose it. Because a quit does not come through and close these files. And you may have part of a file sitting here, part of a print statement sitting in here that never was written out to the disk drive. And that's why you should type in by. By will close the files. And when the files are closed, they go through here and it says, wait a minute, there's still stuff in the buffer here to be written out to the disk, and I'll write it out, then I'll close the file out. And that's how that works. And the very bottom down here, there are 11 bytes, and in this area you'll find the name of the file that was last talked to. So if you did an open number 1, hello, or my name, or whatever, that will be down here. As well as the disk drive number is also following. So, that's basically what's happening with BDP RAM. Now, if you have memory expansion hooked up, then the line number table and extended basic program get moved out here. But the variables stay out here, and the pad stays in here. And that's basically what's going on. Questions, please? Yes?
The first chart on the left shows 0 to FF.
Yes.
I can't read the addresses on the other, but
They also,
are there overlaps in there?
no, this is 0 through 3 FFF, but it's a different block of memory. See, this is a memory map device. So we have a 1 byte window that comes in here, and this 1 byte window can then talk to this whole area. It's just a little tiny window that we're looking at in here. And that one window then expands itself out to look in this whole area. There's no conflict here whatsoever, because you'll also find that this goes from 0 to, well, not actual use, but it goes to FFF also, FFFFF. So there are no overlaps because these are memory map devices. So basically what it is you have a block of memory, and somewhere in that block of memory we have a port. And that port now allows us to come out and talk to another big block of memory, any place that we want in that other block of memory. That's the way that they expanded the size of this computer. See, the microprocessor itself, the way that it's currently set up, will talk directly to 64K. And this is how they got beyond that 64K limitation to allow us to talk to basically 48K of GROM and 16K of BDP RAM. And that's how they expanded it that way.
Where's the window for the cartridge?
The cartridge ROM is also in the memory map device area. There, the window is also there are 4 windows in this area basically, and those windows talk to sound, speech, GROM, and BDP RAM. If I get a chance to run this program, I'll show you where they are. You can see them very easily. Yeah.
Do we have access to the pixels on the screen?
Direct?
Yeah, through post or anything?
No. Basically, in basic or extended basic, you have access to full characters. You can turn it on into bitmap mode, and at that time you have access to pixels, but it's not, you cannot individually turn on and off and designate different colors for each and every individual pixel. And you're limited to 4 pixels wide. So you can define basically what you do is you define the color for a 4 pixel wide block, and within that block you have some pixels on, some pixels off. And the ones that are on will become the one color, once they're off. So,
do we have access to those pixels?
Not in extended basic or basic. In assembly language, yes. And in Forth, yes. The routines were put out there. In Forth, you have split. graphics too.
Where's the information located?
The information is best located. There's a little bit in the editor assembly manual, and the rest of it is in here. This is TI's data manual on the TMS 9918A video display processor. It covers 2 other chips also, but in this manual it talks about how the character sets come together. It also talks about bitmap mode, multicolor mode, what registers need to be set to where. It talks about how to interface this chip. It talks about all the sprites and everything else. It's a nice data manual. So it's somewhat, it can be considered somewhat on the technical side in certain areas. Some of it I don't understand. When it gets into the hardware timing and stuff, I just write software.
Where do you get that book?
TI.
I believe that book is out of publication, is it not?
What's that?
Is that book outdated?
I don't know.
I think the other one has been replaced.
This says November '82 on it, and it has a Texas Instruments address, Post Office Box 1443. What we'll do is we'll put this address and stuff up on the board a little bit. I think the manual was $2. If it's out of print, I don't know now. But the last time I looked in a TI data manual list, it was still there. But I haven't gotten a current one in the last 4 or 5 months, George, so it may be out of print, like you said. But that's where you'll find most of the information on how to talk to that BDP chip. Okay? Next question.
Well, that standard TI card is, what is it, 20, 38K,
32K?
32K? How does that fit into that program?
The memory expansion card?
Yeah.
How does the memory expansion card fit into here? Okay. When you plug a memory expansion card into your key box, part of it is mapped in here, low memory expansion. 8K of it is put into here. And then the balance of it is mapped into this area here of 24K. They split our memory expansion up, unfortunately. Yeah, that's where the 32K. Now, when you type in size and extended basic, you only get 24 something available. That's just this space that extended basic is reporting the size on. Just this space. It's not concerned with this space at all. Yes, go ahead.
You were saying they had 256 bytes of 16-bit wide memory. You said something about before that could be used.
Well,
put that to work.
no, you have to modify the question. I'm going to repeat the question. The question was, can we use more than the 256 bytes? We have a Scratchpad RAM sits on a 1,000-byte boundary, but we only use 256 bytes of it. And you can use more. It requires a hardware modification, I understand. So we're back to hardware again. You guys are asking hardware questions. I understand you have to do something with some of the address lines to decode the second chip and put it into another block. But there are problems encountered with this. Some of the software wants the Scratchpad to be a hex 8300, which is where it's at. Some of the software writes to hex 8100. And if you put a second 256 bytes out there and try and use it, that software will overwrite whatever you put out there. Because of the way that TI decoded, as they call it, decoded the Scratchpad RAM, you can write to 8000, 8100, 8200, 8300, and they'll all be the same. So whatever you write to 8000, if you look at memory, it's all the same all the way down the road. And that's just the way the chip is decoded. It's kind of like it's shadowed. It's just that we're back to the technical how or why, I'm not sure. Yeah?
In extended basic, when you type something, you press enter, and you press function renew, and you wind back.
Yeah.
Where is that stored in memory? Where is the buffer?
Oh, okay. Yeah, where is they call it the edit recall buffer. Okay. And the question was, where is the edit recall buffer in memory? It's in BDP RAM is where it's at. And it's at hex 08CO through 0957. That's the edit recall buffer. And it's in there normal. It hasn't been crunched or anything at that time, the way it's sitting there. Yeah.
What did you mean when you said the editor assembler, there's nothing there?
Oh, in this, the question is, I had mentioned earlier that when you have the editor assembler module plugged in, there was nothing in a given area of memory. And what I was referring to is, in this cartridge ROM RAM space, the editor assembler module does not have any ROM in it, and it doesn't have any RAM. It only has GROM in it. And so when you plug that module in, there's nothing in this space. But there is GROM, and that's how the module works. And basically all that's in that module is just the prompts for the loader, more or less. You know, all the things that come up on the screen, that's basically all that's in that module. I believe there's only one GROM chip, or 6K, in the editor assembler module. Almost every